welcome back to Organic Chemistry Lecture Series. Today I have a treat for you. We're going to do some really interesting mechanisms today, right? These are some of my favorite mechanisms of all semester. These are some exciting mechanisms that we can do, really taking all those parts that we learned from the different carboxylic acid mechanisms that we've been going over and really combine them into one type of mechanism, right? And so what we're going to look at today is this idea that I can take take a bromine. Doesn't look very exciting, right? Not much we can do with that, but I'm going to react it with sodium cyanide. And we know sodium is going to be positive. We know this group's going to be negative. And so we're going to do what? We're going to do a nucleophilic substitution, and SN2. So that what? We can make this group here, right? We can make a nitrile. Right? And so now we can make our nitrile. And what's interesting about these nitriles is that they have some interesting properties when we start reacting them with under acidic conditions, under basic conditions, using Grignards, and then also using it with the hydride as well. And it has an interesting mechanism because again, that group there, if we look at it, cross out again, we have this triple bond between this carbon and the nitrogen. So that's going to make the mechanisms a little more interesting, right? A little more interesting. We're ready for some interesting stuff. It's getting kind of boring, so we're going to shake things up today, and we're going to do some new types of mechanisms with this group here. Okay? So what we'll do here, let's go ahead and we'll erase our board, give us a little more room to work with. I like to have a lot of room to do these new mechanisms with our nitrile groups. So let's take this one here, and let's do an acid catalyzed reaction. So let's dispose this to some acid catalyzed here. Again, I'm not going to tell you what the product is right now. I just want to just do the mechanism because it's pretty interesting. I don't really care much about the product. I more care about the mechanism because it's pretty exciting. So I have an acid. I have my nitrile. What's going to happen first? What do you think? Right? What do you think? Well, remember here, I didn't draw everything in. I'm missing something. Lone pair of electrons. Let's go ahead. Let's take this lone pair of electrons and let's take a proton. And we get to the species here. Got that positive charge there, right? What are we going to do now? Everything we've been doing for so long, right? Positive charge nitrogen. We got these pi bonds to work with. Let's move one over. All right, we get to this form here. Look at that. We move those electrons over, so now we generate a carbocation, right? Generate a carbocation. Ooh, it's pretty exciting, right? Got that carbocation again. What are you going to think we're going to attack the carbocation with? You know it. Water, right? Acid catalyzed with water. H0 plus right there. Now we have our water. It's going to attack. And we get this. Right? We'll redraw that, look a little nicer. Okay. So we get an oxygen there with a positive charge on it, right? Again, what do you think we're going to do now? I bet we know, we've seen this multiple times. There's a lone pair here with nitrogen. Let's do a boom. Let's do that proton transfer. Let's bring those hydrogen over to that nitrogen. I want some hydrogens. All right, now we got a positive charge on nitrogen. What do you want to do now? Nitrogen cannot be positively charged. It doesn't want to be positively charged. How can we make it neutral? It needs electrons. How can we give it electrons? We know it. We know this. We're going to do resonance. Great. Maybe this is why I like this mechanism, because we get to do already this mechanism. We've done how many times we've done resonance? We've done resonance already. Once already. This is our second time doing our resonance structure. Look at that. Positive charge in the carbon. Positive charge in the carbon. What do you want to do now? Uh-oh. Let's do our resonance. Right? Electrons move there. Positive charge, electrons move there. we could do this all in one step. I could move these electrons here and then move these lone pair from the oxygen down all in one step. But I'm going to do it over 2 steps because can't get enough resonance, right? All right, so we're at this form here. Now we have this oxygen with a positive charge on it, right? I'll make a little poorly drawn oxygen. And then do what's going to be our last step. Remember, anytime we do these mechanisms, we've always seen these before. It's like first step is protonation. Last step should be deprotonation, right? You're going to deprotonate. Notice that. Right? And so what did we form then? What did we make? We made a amide. Right? We're able to take our nitrile, using acid catalyzed conditions, we're able to make our amide. Okay? Briefly, what did we do? We took our nitrogen, took off a proton, resonance, carbocation, we attacked it, proton transfer, and then we did resonance, right? This is the big resonance here. Now again, I show this in 2 steps. You could do the resonance in 1 step, moving these electrons here, these ones up there. I like to do it in 2, right? And then we get carbocation, electrons come down. And then now what's our last step? We got deprotonated. Deprotonated to form our amide, right? So it's a pretty interesting mechanism to go through in this case here, right? Using acid catalyzed version. What do you think will happen now if we can we do the same mechanism now with, how about base catalyzed, with base in water, right? What do you think we're going to see? Probably something very similar, right? Something very, very similar. So let's try that next mechanism. Let's try it with our base. All right, now that we're all warmed up, let's see what the base catalyzed version is going to look like. Again, as we start these, what are we going to do first? I'll make sure I'll put water there because we have water in the reaction. So it's going to be our base catalyzed version, right? Base catalyzed. Must focus on. Technical difficulties, right? We're just trying to get some videos made. My camera has some problems. All right. Whoa. Okay. So we got OH group. We want to attack something. What do you want to attack, right? We're going to attack nitrogen or carbon, right? Which one do you want to attack? As we said before, I think our better one to attack would be what? Be our carbon. Again, as we attack that carbon, we need the electrons need to move, right? Make way for that oxygen group. So let's move those electrons there to that nitrogen. Right? Now this nitrogen is negatively charged, right? We don't want a negatively charged nitrogen. What's going to happen? Now, remember, we have water in this reaction. So what we're going to see now is our water is going to come in. Right? Our water is going to come in, and now nitrogen is going to pull off hydrogen from that water, right? We're going to pull one off. Oops. And so we get to this species here, right? Where we now have the nitrogen has this charge on there, right? Nitrogen's neutral now. Everything looks great. And then we're going to bring our base in again, because we just made some base. And now this base is going to pull off this proton here. Okay, negative charge here. And notice what's going to happen now. Now that we've this OH group pulled off a proton here, now we have negative charge on this oxygen. And so what we can do there, we can again do our resonance structure. Resonance electrons come in here, we're going to kick electrons out like that, right? Again, going through that resonance structure there. Again, it makes that negative charge on nitrogen. You can see we're kind of taking shape. It's forming that amide group now, right? So what's going to be our last step? Water's going to come in. And again, we form our what? We're going to form our amide again, right? Notice in this reaction here is that we go ahead and have the OH group attacks the carbon, electrons moved up. We go over to nitrogen, negative charge. This pulled off a hydrogen from the water. We get this species here. Once we do that, then this OH group is going to pull off a hydrogen here to generate a negative charge in the oxygen. Electrons are going to go collapse down to make our carbonyl, which is going to force the electrons to go to the nitrogen. And we get that negative charge on nitrogen. Negative charge on nitrogen is going to pull a hydrogen to generate our amide group here, right? And so we can see with both our acid catalyzed and our base catalyzed version, we take our nitrile group and convert it into an amide, either way, right? So it's a pretty interesting mechanism of how this went through. I like the acid catalyzed one a little bit better. It's a little bit nicer of a mechanism. This one works well too. It's a little, maybe because it's a little bit shorter. I like those longer mechanisms, right? A lot nicer. So this is the way we can do this as well, right? So two ways, using acid catalyzed and base catalyzed, take a nitrile, turn it into an amide, right? In our next video, I'm excited to see how we can then take our Grignards and our lithium hydride to do some more chemistry with our nitrile groups. And what can we turn this nitrile group into? Exposing it to Grignards, and also then using a lithium hydride.